Everyone is talking about AI right now. AI writes emails, AI writes code, AI passes exams. Some people even say AI is already smarter than humans. But let me ask you a fairly simple question. Why can't AI clean your table? Not build a rocket, not discover medicine. Just clean a messy table. A 5-year-old child can do it. Pick up the cup, throw away the rubbish. Simple, right? The same AI that can write a university essay, but it cannot pick up a sock from the floor. Now, something changed recently. CES 2026, held in early January 2026 in Las Vegas, marked a key shift where AI discussions moved from digital tools such as chatbots and generative models to AI embodied in the physical world through robots, humanoids, autonomous systems, and interactive machines. NVIDIA's Jensen Huang emphasized the physical AI in his keynote, tying it to robotic and autonomous systems. For the first time, the tech world started calling this the beginning of physical AI. So, maybe what we called AI for the past 10 years was only the thinking half of intelligence. Because the real world is not made of words. It is made of objects, space, uncertainty, and physics. And for more than 15 years, this has been the war AI could never cause. Until now. To understand why, we first need to talk about a misunderstanding. We think AI already exists. For the past 2 years, we have been watching something extraordinary. ChatGPT, Gemini, Copilot. They can pass the bar exam. They can pass medical licensing exams. They score in the top percentiles of the SAT. In mathematics and coding, AI systems already perform at the level of human experts in certain verifiable domains. They can write a business proposal, summarize a 300-page report, debug your code, compose music, generate photorealistic images, and they do all this in seconds. So, naturally, we look at this and think AI is already intelligent. The revolution has already happened, right? But let me ask you something simple. AI can write a recipe for scrambled eggs in any language. But it cannot crack an egg. It can generate a beautiful picture. But he cannot hang a picture on a wall. It can find you a recipe. But it cannot cook you dinner. That sounds almost funny. But it reveals something very deep. There is a famous idea in AI called Moravec paradox. It says, the things humans find difficult, like advanced mathematics or formal reasoning, are actually easy for machines. But the things humans find effortless, like walking, grasping, recognizing objects, navigating space, are incredibly difficult for machines. Why? Because encoded in the sensory and motor system of the human being is nearly 1 billion years of evolutionary experience about how to survive in the physical world. What we call reasoning, solving equations, passing exams, is actually just a thin layer on top of something much older and more powerful. Sensorimotor intelligence. The intelligence of moving, touching, balancing, predicting. And today's AI mostly has the thin layer. It is brilliant at reasoning in text, but it lacks the deep physical foundation underneath. To understand this, think about the difference between two worlds. The world inside a computer and the real world. Inside a computer, everything is clear, structured, reversible, safe, no real consequence. If you type the wrong word, you delete it. In the real world, everything is noisy, ambiguous, irreversible, sometimes dangerous. And this is always a price. If you drop a glass, it shatters forever. There's no undo button in reality. This is why passing exam does not mean functioning in life. For 17 years, AI research focused on things that are measurable and digital. Chess, mathematics, logic, language. And every time AI improved at those tasks, we said, we are getting close to real intelligence. But intelligence did not evolve to pass exams. It evolved to survive in the physical world, to move, to predict, to avoid danger, to manipulate objects. We were not measuring the wrong technology. We were measuring the wrong thing. So, here is the uncomfortable truth. Today's AI is incredibly powerful, but it is a brain without a body. A brain without a body is only half an intelligence. But here is the deeper question. Why does the body matter so much? Why has building physical intelligence been so unbelievably difficult? After all, humans do it effortlessly. So, if this feels easy for us, why has it defeated machines for over 15 years? Let's do a simple thought experiment. Imagine you walk into your kitchen. Instantly, without effort, you know which cup is yours, which plate is dirty, what may spill, what is fragile, where it is safe to step. You don't calculate, you don't analyze, you just know. Now, imagine replacing you with a camera. The camera doesn't see your cup, it sees pixels. It doesn't see dirty plate, it sees color patterns. It doesn't see dangerous knife, it sees a metallic shape. It doesn't see web 4, it sees light reflection. It doesn't see chair to sit, it sees geometry. Humans don't see objects, we see meaning. And for AI, the gap between pixels and meaning is enormous because AI must convert pixels to understanding, to action. And that middle step, understanding, is extremely hard. Recognition is not understanding. Identifying a knife is one thing. Understanding that it can cut you, that it must be handled carefully, that it doesn't belong near a child, that's something deeper. Now, let's talk about why the real world is so hostile to intelligence. First, unpredictably, the digital world is finite. Internet text, photos, videos, huge, yes, but bound. The physical world, infinite combinations. A robot may train perfectly on 10,000 kitchens, but your kitchen has that one weird drawer that sticks. lighting that changes every hour, a plastic bag that moves unpredictably, a cat that suddenly jumps onto the counter. They are called long-tail problems, rare events, edge cases, one in a million situations. But in the real world, those rare events happen all the time, and no dataset can capture them all. A single spoon can exist in thousands of states: clean, dirty, bent, wet, inside a cup, under a plate, half hidden. Engineers could not just write rules for everything. That's why factories work. Factories remove uncertainty. Same objects, same lighting, same positions. Homes failed because homes contain maximum uncertainty. Now, add physics, gravity, friction, soft objects, fluid spills. These are not suggestions. They are laws. In a simulation, you can reset and try again. In reality, drop an egg, it is gone. Knock over a vase, shattered. Make a mistake, no undo button. Training ChatGPT allows millions of harmless errors. Training a household robot, one wrong move, broken glass, injured person, damaged machine. The real world is irreversible, and intelligence must operate inside consequences. So, how do humans manage this so effortlessly? We don't solve equations. We don't calculate thought before opening a door. We build intuitions through interaction. Babies drop objects. They touch hot surfaces. They spill water. They fall down. Through thousands of small failures, we build a predictive model of reality. We learn, if I push this, it moves. If I tilt this, it spills. If I step here, I slip. Intelligence is prediction under uncertainty. And humans solve this not through calculation, but through experience. For decades, AI had data, but it didn't have experience. It had descriptions of the world, but it didn't live in the world. And this is the invisible barrier. If intelligence is about handling reality, then intelligence cannot exist only inside a brain. It must come from interaction. Maybe the body is not controlled by intelligence. Maybe the body creates intelligence. And that's where the real story begins.